I think we're going to get started.
Fantastic.
I think we're going to get started. Can you hear me? Okay. Is this all right? No? Anybody know how we control mic volume? You know. A little up? Yeah, a little up. Okay, is that better? Yes? Okay, welcome to tonight's panel. My name is Ben Hurlbut. I'm from Arizona State University, and tonight I have the pleasure and privilege of introducing our distinguished speakers, the last one of which has just arrived in the nick of time. Hi, George. You can take this chair, and I'll pull one in afterwards. Whatever you prefer. But before I make introductions, let me say a brief word about what brings us here tonight. So this is the opening panel of a larger workshop that explores the social, political, and ethical implications of new technologies of genome editing. The advent of technologies of genome editing have opened a new chapter in the history of biotechnology, offering means to achieve precise, targeted, reliable genetic modifications in virtually any organism from microbe to mammal. The advent of CRISPR-Cas9 in particular has made genome editing cheap, as one commentator has put it, cheap, quick, and easy to use, thereby radically expanding capacities to modify genomes, organisms, and even ecosystems. Of the many potential applications of genome editing, perhaps the most ethically challenging are those that would make heritable genetic alterations in human beings. The potential for editing the human germline has elicited an international debate about human integrity at the frontiers of biology and about what norms should guide these editorial aspirations. Tonight's panel and the workshop that will follow it tomorrow will build upon that debate. However, while genome editing is our entry point for conversation, the questions that are at stake here transcend the technologies of the moment. They touch upon questions of human integrity, of our responsibilities to future generations, and perhaps most challenging, of how societies and indeed the whole human community should make judgments about what biotechnological futures to welcome or refuse. In December 2015, the US National Academies, together with the Chinese Academy of Sciences and the UK Royal Society, convened an international summit on human gene editing. The summit organizers affirmed that CRISPR-Cas9 and related technologies pose novel governance challenges because they affect the future of the human species and hence the entire global community. Summit leaders called for a halt to clinical uses of germline gene editing until there's a demonstration of safety and a, quote, broad societal consensus about the appropriateness of the proposed application. They called also for an international forum embracing, quote, a wide range of perspectives and expertise, end quote, to establish norms for distinguishing between acceptable and unacceptable applications. With the call for the international forum, more than gene editing is at stake. The approaches that are developed now will very likely create precedents for the future governance of new and emerging biotechnologies, just as the famous 1975 Asilomar meeting on recombinant DNA informed the vision for the 2015 summit. Yet, governance approaches that have taken shape in the last 4 decades have generally relied upon forms of risk assessment and institutional oversight that allow relatively little opportunity for the kind of wide and diverse public engagement called for in governing human genome editing. Indeed, there's an emerging consensus that the present challenges demand different approaches, new sorts of approaches that allow for more inclusive conversations about what's at stake, scientifically, socially, ethically, and politically. And the stakes are high. Human genome editing touches upon fundamental questions of human integrity, and hence upon deeply held cultural, moral, and religious ideas that form the foundations of constitutional governance in most societies. In order to develop robust approaches to evaluating and governing these technologies, we must ask, what are the appropriate processes for determining the directions of future research, and indeed for determining when we have achieved the sort of broad societal consensus that the summit organizers called for? What modes and mechanisms of participation, deliberation, and representation are required? What are the rights, roles, and responsibilities of scientific experts, policymakers, and publics in such processes? And are existing scientific and political institutions up to the task? Where not, what innovations in democracy must accompany and inform technological innovation? So tonight's panel and tomorrow's workshop will begin to tackle these rather tough questions by drawing together a diverse and distinguished group of scientists, scholars, legal and policy professionals, religious thinkers, and civil society representatives. Before I move on to introducing our speakers, though, let me first acknowledge the sponsors of this gathering. So this meeting is hosted by the Harvard Program on Science, Technology, and Society, whose director, Sheila Jasanoff, is one of our panelists. The aims of the meeting reflects the mission of the STS program in general, to deepen our understanding at the nexus of science and technology with social and political life. It's also co-sponsored by the Center for Biology and Society at Arizona State University with generous support from the Templeton Religion Trust, the Petrie-Flom Center for Health Law Policy, Biotechnology, and Bioethics at Harvard Law School, and the Center for Bioethics at Harvard Medical School with generous support from the Oswald de Kamen Fund, the Institute for Global Law and Policy at Harvard Law School, the Future Society, the Weatherhead Center for International Affairs. So I think you'll agree from the profile of these sponsors that this sort of mix of sponsors reflects the diverse domains of biology, medicine, law, ethics, and international governance that this topic requires us to engage with. So we're most grateful for the collaboration and support of these numerous sponsors. So now let me introduce our speakers. So our first speaker tonight is George Church. Professor Church is Robert Winthrop Professor of Genetics at Harvard Medical School and Professor of Health Sciences and Technology at Harvard and MIT. He was a founding member of the Wyss Institute for Biologically Inspired Engineering at Harvard. He's a towering figure in biotechnology, both figuratively and literally. His innovations have contributed to nearly all next-generation DNA sequencing methods and companies. He's developed methods that were used for the first genome sequence and has played an instrumental role in bringing about the million-fold reduction in the cost of sequencing a human genome, a really remarkable technological achievement. He co-initiated the Human Genome Project and the BRAIN Initiative. He's co-authored hundreds and hundreds of scientific papers, holds nearly 100 patents, although that figure may be outdated since they seem to accumulate weekly, has started so many companies that his conflict of interest slide is actually legendary. Let's just say it takes a long time to read it. His research extends into a remarkable range of domains, including stem cell biology, bioengineering, and he's made some of the most important scientific contributions to the technologies we're discussing tonight. Yet his contributions to the world of biotechnology go beyond the science and technology alone. He's the founder and first participant in the Personal Genome Project, an open access human genomic database that contributes not only to the scientific and medical potential of human genomics, but to experimentation and novel approaches to access to personal genomic and health data, in part to foster social and ethical engagement with questions about cultures of privacy and research participation. It's rare, my sense is, it's rare to encounter a figure like Professor Church, who is simultaneously driving the frontiers of biotechnology and engaging seriously with its social and ethical meanings. On this score, by the way, I highly recommend his book, Regenesis. Our next speaker will be Feng Zhang. He is a McGovern investigator and associate professor in the departments of brain and cognitive sciences and of biological engineering at MIT. He's also a core member of the Broad Institute. Originally from China, he grew up in Iowa. He received his AB in chemistry and physics from Harvard College and his PhD in chemistry from Stanford University. He's received many awards for his work in genome editing and optogenetics, including the Pearl UNC Prize in Neuroscience, the NIH Director's Pioneer Award, the National Science Foundation's Alan T. Waterman Award, the Jacob Heskel Gabby Award in Biotechnology and Medicine, the Society for Neuroscience Young Investigator Award, the Okazaki Award, and I could go on at length. He made some of the most foundational advances in CRISPR-based genome editing, about which he will talk tonight. He's also a founder of Editas Medicine, a genome editing company that was formed by a group of the world leaders in the fields of genome editing, protein engineering, and molecular and structural biology. Our next speaker will be Glenn Cohen. The name Glenn Cohen is essentially synonymous with bioethics and law at Harvard Law School. He was a member of the inaugural cohort of the Petrie-Flom Academic Fellows, and then was appointed to the Harvard Law School faculty and is currently faculty director of the Petrie-Flom Center, a path that I think all subsequent Petrie-Flom fellows have tried and failed to replicate. He is one of the world's leading experts on the intersection of bioethics law, life sciences, and medicine. His really immense body of scholarly work, covers an extraordinarily broad territory and with extraordinary depth. An internationally recognized expert, he's spoken to audiences of all sorts around the world, scientific, legal, industry, government, and more, and is frequently called upon by the media to comment on issues at the intersection of law and the life sciences. Our next speaker will be Sheila Jasanoff. Sheila Jasanoff is Forsheimer Professor of Science and Technology Studies at the Harvard Kennedy School. She is a pioneering figure in STS, has authored more than 120 articles and chapters, and is author or editor of more than 15 books, including The Fifth Branch, Science at the Bar, Designs on Nature, and most recently, The Ethics of Innovation, a wonderful book that I recommend to all of you. Her work explores the role of science and technology in the law, politics, and policy of modern democracies, with particular attention to the nature of public reason in these domains. She was founding chair of the STS department at Cornell University and has held numerous distinguished visiting appointments internationally. She's an internationally recognized scholar at the intersection of science, law, policy, and politics, and her research spans a remarkable breadth of empirical domains, from climate and environment to chemicals regulation to biotechnology, to name just a few. In addition to making foundational contributions to the field of STS itself, she's also built the vibrant STS program at Harvard. She's the founding director of that program, a program I came out of. It's an academic space, I can attest, whose intellectual vibrancy is truly exceptional, even at an institution with as much to offer as Harvard. She brings a wealth of knowledge and expertise not only to the field of STS, but to the many other fields and communities with which she's engaged, from law to science to ethics and to domains of public policy. Last but not least is our final speaker, Professor Kwame Anthony Appiah, who you will note is not with us. He is probably in the air just above Logan. Was delayed. His flight was delayed because of the bad weather, and promises that he is going to deplane, hop in a taxi, and race over here as fast as possible. So hopefully we will have at least some of them sometime with him tonight. In case that's the case, I'm going to go ahead and introduce him, in part because I think I'm going to just go ahead and read his talk. It will be fun to play Anthony Appiah. So he was educated at Clare College at Cambridge University in England, where he took both a BA and PhD degrees in the philosophy department. He's taught at Yale, Cornell, Duke, Harvard, and Princeton, where he had appointments in philosophy and the University Center for Human Values, and was also associated with the Center for African American Studies, the programs in African Studies and Translation Studies, and the departments of Comparative Literature and Politics. In 2014, he took up an appointment as professor of philosophy and law at New York University, where he teaches both in New York and Abu Dhabi and at other NYU global centers. He's author of numerous books, including Ethics in a World of Strangers and the Ethics of Identity, Experiments in Ethics, and particularly relevant to our topic today, Cosmopolitanism. This is a book that I just read. It's really a wonderful book. Somehow it manages to be philosophically rich, highly readable, and of great relevance to contemporary political life, a trifecta not so common in philosophical writing. But that's perhaps not surprising, given the fact that many people in this room have probably already looked to and even heeded Professor Appiah's ethical guidance. He is the author of the weekly ethicist column in the New York Times. So let us welcome our distinguished panel. And with that, I will turn it over to you, George. Do you prefer to sit or stand?
Oh, I far prefer to stand.
Okay.
Yeah. So I'll just keep standing after I'm done. Yeah. So I will keep my comments brief, hopefully. How much time do we have?
10 minutes.
10 minutes. Okay. Probably less than that. I think one of the core questions that we have here is not just about what applications of technology we as individuals might consider desirable or undesirable. It's also the equitable distribution of these technologies and the involvement in personal choice. To enable that personal choice in a world with 7 billion souls is quite daunting. There are very few technologies, if any, that are equitably distributed fully. I will give one example, just so that you know that there is an example of a technology that is equitably distributed. Can you think of one? The one that comes to my mind is resistance to smallpox. All 7.5 billion of us are no longer at risk to smallpox, which is a devastating disease, because it is extinct. It is very hard to equitably distribute even technologies as inexpensive as vaccines, but if you take a vaccine to the point of extinction, and there are many diseases in the world which are human-specific, not just smallpox, but polio, guinea worm, HIV, and the list goes on, then you have something that is equitably distributed. Now, how does that apply to tonight's topic? The gene therapy, for example, broadening the topic from editing, which I think is much too narrow a topic, to gene therapy broadly, is now the most expensive therapeutic in history. It is the first one approved in Europe. Glybera is $1.3 million per dose. Now that can come down if it is a particularly rare disease, so-called orphan disease. It will stay up there because there is a fixed cost, right? At least in the current technological and regulatory structure, a fixed cost for safety and efficacy testing. But if you have a larger problem, a problem that affects everybody in the world, for example, and enough time to defray the costs of that study and enough doses, enough people, it can come down radically. There's nothing intrinsic about the manufacturing of gene therapies that is expensive. In fact, there are veterinary gene therapies that are being developed that will be low cost, that are already low cost. So we're doing these in our laboratory that are extraordinarily low cost. There are do-it-yourself gene therapists, which raises another interesting set of ethical questions. People who have manufactured their own gene therapies that are not particularly well off. They certainly are not the least wealthy people in the world, but they're typical citizens that have manufactured themselves. So the point is we're paying for the regulatory safety and efficacy. Now there are many ethical questions that I'm sure we will explore tonight in detail that go beyond safety and efficacy. There are issues that go beyond equitable distribution as well. There are issues where there may be goals that involve commoditization of human nature, of our relationship with our children and our longer-term descendants that go beyond safety and efficacy. I think at some level they involve the safety of our planet, of our inheritance, of our social norms and so forth, but they're not properly described in the kind of safety and efficacy that the Food and Drug Administration oversees. I think we need to consider these quite frankly. Furthermore, we are dealing with a different kind of problem than we dealt with the eugenics of not so long ago. I think it was as recently as 1963, the United States was finally winding down its eugenics, where we sterilized between somewhere around 60,000, 70,000 people against their will. The important thing there is against their will. What we have now is a potential for regulating where we once again are restricting choice, where we're saying we, the majority, don't think that you should engineer sperm to eliminate Tay-Sachs disease. We, the majority, think that you shouldn't do that. But does the minority have the right to, if they have a devastating disease in their family or in their community, to take action? We have cases where embryo life is considered quite significant by about half of our population. If we come up with an alternative to abortion and in vitro fertilization, which is currently the medical norms, does that get a different set of ethical considerations? If we can alter the gametes in a way that's proven to be safe and effective, we use it to address a social norm that goes beyond safety and efficacy, such as the respect for embryos that some people, but certainly not all people, have? There's some very important discussions to be had here. And that finally, that gets us to the point of getting back to my original topic, which was equitable distribution. If you give everybody the right to make their own decisions, and you give them the economic wherewithal by bringing down the cost very radically, as we have for some technologies, including, cell phones and sequencing, then you have the problem. You have to make sure that they understand what they're getting into. You could suddenly deliver to them very inexpensive power over their own bodies, their own families, and they could still be very unhappy, unsatisfied with the outcome if they're not properly prepared. And so that discussion is extremely difficult when we apply it to 7.5 billion people. So I'll leave it there for now.
Good evening. It's really a great pleasure to be here, especially with such a distinguished panel. I thought maybe I'll just give you a primer on gene editing. So you probably have read in newspapers about what gene editing is, and maybe even heard about designer babies and all these other things that are being talked about. So what is this technology that we're talking about? What is the underlying thing? So the technology that has gotten a lot of people excited in the past several years is something called CRISPR-Cas9 based genome editing. And you may ask, why is this thing interesting, and why do we need it? What is it good for? Well, to understand that, let's go back a little bit. So in the past several decades, our understanding of human genetics has advanced tremendously. And so with that, we're now able to identify over 6,000 different genetic mutations that underlie disease. And we have also identified mutations that prevent people from having disease or significantly reduce their risk. So for example, about 5 to 8% of the population carry a gene mutation in something called CCR5. And those individuals, they are significantly less likely to get infected by HIV virus. And so you may be sitting there now and thinking, if we know what mutations are deleterious, which ones cause disease, and we also know which ones are potentially beneficial, why don't we just go into our genomes, get rid of those bad ones, and put in the beneficial ones? This is where gene editing comes in, because it turns out our genome is microscopic, and we have many, many cells. To make a very precise change to undo a deleterious mutation or to install a new beneficial mutation is quite challenging. So how do we actually do that? Well, the human genome is about 3 billion letters long. So imagine that as a book. And if this book was inside a Microsoft Word, this is a pretty trivial thing to do. If you know what mutation it is, or what typo it is in this book, you would open up the search function, you type in that typo, and then Word will take your cursor to exactly where that typo is. Once that cursor is placed, you can backspace on the keyboard, you can type in the new sequence you want, or the new word you want to replace in the document. This is all pretty easy to do. But what if that book of the genome is inside of the nucleus of our cell? Well, it turns out that there is an alternative way to do this search and replace function, and that's where this CRISPR-Cas9 system comes about. So CRISPR-Cas9 is from a bacterial immune system called CRISPR. And the way it works is that bacteria like us in nature, we can get infected by viruses, and bacteria have their own immune system that uses DNA to encode RNA recognition sequences that are obtained from previous viruses to be able to mount a defense against new virus infection. So when a new virus comes in and infects the bacterial cell, these RNA sequences get produced by the bacteria, and then that RNA goes in and compares with the DNA along with the help of this enzyme called Cas9, so that if the RNA matches with the DNA, Cas9 cuts it, snips it. In the context of virus infection, that inactivates the virus, which is good for the bacteria. But in the human genome, in the context of genome editing, that cut is the equivalent of a Microsoft Word cursor. So wherever we cut in the genome, by programming Cas9 with a short RNA sequence that takes it to the mutation that we want to fix, Cas9 will cut it, and then that can stimulate the cell to try to repair that DNA cut. There are two ways that we can go about doing that. One way is called non-homologous enjoining, but all you have to remember is that it just stitches the two ends of DNA together. But in the process of doing so, a small mutation can get introduced. And that's beneficial if we wanted to inactivate a gene or if you want to cut out a specific sequence. The second method is more powerful. It's called homology-directed repair, where you can provide a template strand of DNA. This is the string of sequence that you want to swap into the genome. And through a series of repair processes in the cell, that sequence can get swapped into the genome. So this is how we kind of go about doing gene editing, using this enzyme called Cas9 and programming it with the RNA sequence to then make a cut in the genome. Since then, even better technology have been developed where we can use Cas9 to direct what's called enzymes to be able to modify specific DNA bases or to be able to turn genes on or turn genes off without actually modifying the DNA sequence. And so this whole ability to be able to direct a specific protein to search in the book of the genome and to find a specific site and place the cursor or latch there, that's what's enabling a lot of these recent advances. So there are many different applications of CRISPR genome editing, and there are about 3 areas where this is really gaining a lot of momentum. One of the areas is in developing new drugs. Genome editing is providing a new potential to be able to develop curative medicine, where if we know what mutations cause disease, through a single shot, one-time administration of this genome editing-based drug, we may be able to undo that mutation and then provide a permanent treatment, permanent cure for the disease. So that's very exciting. But beyond that, we can also use the system to drastically accelerate the pace of research. It's a tool that's really easy to use and it's efficient and inexpensive. And so that means researchers now around the world are using this to study different disease and biological processes. You can make mouse models in a fraction amount of time that it used to take. And you can not limit yourself just to mouse models. You can make rat models, non-human primate models, and directly work with human cells to be able to model a specific disease in exactly the right type of system. The third area that's really exciting is in agriculture. As we learn more and more about what genetic traits are important for for different crop species, we can combine them together into the same crop to make it more sustainable, produce higher yield, and really feed the world. We have been doing this for thousands of years now, but that's usually done by crossing and breeding. But with genome editing, we can accelerate that breeding by using techniques like genome editing to put in multiple of these beneficial traits within the same crop. And that can be quite powerful as well. And so these are all the things why the technology has garnered so much attention and excitement. But needless to say, there are also enormous ethical challenges and obstacles that face the technology. On a technical level, there are still things that we need to do to make it more specific, make it more precise, and also make it more efficient so that we can use it in a broad range of applications. But in the ethical area, there are really even more serious concerns. How do we approach the application and development of this technology for treating diseases? People mentioned the concept of editing the germline or editing embryo. These changes would be able to get passed down to future generations. And how should we think about not only the development but future application of the technology? there are also other areas of this technology that's also worth equal kind of debate, and that's something that George has worked on a lot as well, called gene drive, where we can engineer rapidly reproducing organisms to be able to spread genetic traits, and this can spread very rapidly within a large population, and it's unclear whether or not these things are going to be things that we can control once we unleash into the wild. And so from a technical perspective, people are working on trying to engineer regulation into these systems or reversibility. But from an ethical standpoint, do we want to practice this type of bioremediation or bio sort of environmental engineering approaches? So these are just some of the things to talk about, and I'm really looking forward to getting into a active and exciting conversation with you all, and especially with this distinguished panel. Thank you.
Thank you very much. The distinguished novelist Borges once said, "World literature only knows 4 narratives: the siege and defense of a city, a hero's return, a search, and God's sacrifice." That's it. Now, again, I think he might have left out a little bit motherhood, some narratives for women and the like, but it strikes me as not a bad first approximation. Well, if that's world literature, very sophisticated, very delicious kind of setup, bioethics really only knows 2 narratives, right? So what are those 2 narratives? The first narrative, and really the intersection of bioethics and technology, is this technology is brand new, and there are brand new issues to consider, right? That's the first narrative. And I know to the audience to whom I'm playing, so I'll say this is the Star Trek narrative, right? We go out to the frontier, we encounter new challenges, we examine them, we have to rethink our way of life through these encounters. The other narrative is what I'll refer to as the Battlestar Galactica narrative, right? All this has happened before, all this will happen again. And the idea is that the technology may be brand new, but it fits into our existing paradigms. We've thought through this very well. And in fact, the alterations required by bioethics are relatively minor. So new technologies pose old questions that we struggled with quite a lot. It's no doubt that as a matter of science, the last 3 years have probably been the most exciting years for this area of science since the development of in vitro fertilization, may be the most exciting 3 years for a century, even beyond that. We have gene drives and gene editing, which you've already heard about. We also have mitochondrial replacement therapy, taking the mitochondria from one woman and combining it with an egg from another woman to produce what's sometimes referred to as 3-parent IVF. And we have in vitro gametogenesis, taking adult cells like skin cells and inducing them to become gametes. So the idea that a child could be born from your skin as opposed to from, well, your reproductive organs, right? So this is incredibly exciting and disruptive in terms of technological world. But is it really new in terms of the kinds of questions that bioethics have struggled with? So those of you who know me know that I'm very rarely ambivalent, but on this particular topic, I feel quite ambivalent on the answer. And my own sense that I'm going to tell you about is my sense of the ways in which some of the questions are new, but most of the questions are old technology by technology. So to start with gene editing, if I could give a title to George's speech, it might be to borrow from William Gibson, who said, the future is already here, it's just not very evenly distributed, right? So in terms of the idea of the distribution of access to goods and the like, this is an issue with bioethics has struggled with for its entire period, but most recently, I would say in the last 20 or 30 years, as international relations in bioethics and drug availability and the like has become more pressing. It's a familiar issue. Questions about enhancement and how far we ought to go in enhancement, whether it is the Michael Sandel, Leon Kass kind of flavor of the argument, which is this idea of a perversion of our acceptance of the unbidden or turning procreation to manufacture, or more of a kind of idea about positional goods, relativism, and the idea of Gattaca, for example. Again, a relatively familiar set of questions. What is unfamiliar, though, I think, is kind of the struggle with the ways in which existing institutions are or are not well served, particularly in this country, in order to accommodate these technologies. When you look at an institution like FDA is a technocratic institution that has certain expertise in reviewing trials and asking for more data, but not at all well equipped in kind of struggling with ethical questions and questions about how far to go. When you look at a technology like mitochondrial replacement therapy, there are questions that are somewhat familiar. The question about whether the line between somatic versus germline alteration is a real one that is philosophically meritful or not. But then there are a bunch of questions that seem somewhat newish. One has to do with our conception of parenthood, right? So when you have three individuals involved at a genetic level, somewhat familiar from the questions about surrogacy, where we're talking about gestational parentage, but here talking at the level of genetic level contributing, what is our attitudes towards these individuals as parents? And just to give a very tangible instantiation of that question, if you look at the UK, which has authorized the licensing of this technology in the UK, you see that although the UK has a rule prohibiting sperm and egg donor anonymity, you must put your name in a registry, they exempted the mitochondrial donor from this rule, essentially declaring that this person is not a parent, that if you as a child born through this technology want to, as a donor-conceived child, reach out to that person, to your parent, this is not the person you ought to look at. Questions about sex selection. So in the National Academy's recommendations on this subject, really intriguing. They recommend sex selection of the embryos for which mitochondrial replacement can be performed upon in order to avoid germline alteration and passing down the edited, or the changed, I should say, genetic materials to future generations, right? So for the first time ever, a suggestion that perhaps the government ought to enforce rather than prohibit a form of sex selection. That's kind of newish. When we look at in vitro gametogenesis, right, there are again issues that are familiar. Questions about embryo destruction and their ethics, right? What would it mean to create huge numbers of embryo only to see them destroyed? We saw that in the realm of stem cell derivation 20 years ago, 15 years ago. Questions of enhancement, again, somewhat familiar. But then questions that are quite new and interesting, questions about unauthorized parenthood. What would be the relationship to someone who is generated in an unauthorized way from your material? And questions about multiplex parenting, probably still science fictional, or single individual parenting, the idea that you could produce your own opposite gametes and or produce gametes from a contribution of other people. When it comes to gene drives, again, some familiarity. What disaster movie does not have as its trope the creation of a new species that overwhelms us and ends up creating our own demise, right? This is kind of the plot of many a familiar film. But then also lots of new and interesting questions, again, more at the technocratic level in the questions about democracy, right? How do we think about creating a consultation process for changing mosquitoes, for example, in a community, right? Who are the relevant parties that have to be engaged? How do you structure that engagement? And then over all of this, I think there is the most major and important change is just the realization of the globalization of this technology. By creating tools that are, in layman's terms, relatively easy to use, relatively able to be used by not merely a small cadre of individuals in this world, but a much larger community, we opened up the question about how to harmonize multiple jurisdictions and their rules. And this became quite a reality quite quickly. The UK authorized the Newcastle Protocol for mitochondrial replacement therapy. People like me were writing about what will happen when Americans go abroad, use mitochondrial replacement, want to bring these children back. And what did we miss? The fact that, in fact, it would occur not in the UK, where it's been authorized, but in Mexico, where there has been no consultation or discussion on this subject, and it would be Americans going there and the like. So how do you harmonize the law on these issues among multiple jurisdictions? And here's where I go from a talk about wonder and possibility to a talk about deep skepticism, and here it is. So get ready for the tonal change, right? If, in fact, you believe something like consensus is necessary for permission, we are not going to get consensus, right? To the extent we've had familiar issues and familiar discussions, We have boiled things down, I think, to the level, the atomic level. We are much clearer about what the foundational commitments are or are not that different people among us hold. And yet, though, we have not reached consensus, if that is your requirement, let alone unanimity, if that is your requirement, on the right way forward. We are much more likely to see, instead of consensus, freezing in some jurisdictions, moving forward in other jurisdictions, and a grand experiment being run not in a coordinated way, but in a way that is cacophonic and chaotic. Now, whether it turns out that story ends up being a happy story at the end of the day is an open question. But if you think that the way forward in this area is consensus, I am very skeptical that we will achieve that. Thank you.
So the three speakers before me have started to some extent with the promises and the wonder of the science, even when they veered off into skepticism. I want to begin with editing and think a little bit about what one needs to know in order to edit well. It's one of the many aspects of my job that no one ever taught me. Let's begin with one thing. Glenn mentioned Word and editing. Word is extremely annoying in the way it edits. I have a number of books published by the British publisher Routledge. It's spelled R-O-U-T, and Word keeps on picking up this word and giving me two possibilities. One is Routledge spelled R-U-T, ledge, because they believe it should be the phonetic pronunciation, or, much more interestingly, route and ledge. And I think all of you have experienced the spell check on Word, taking complex words and always wanting to separate them out into two words. Now, if they knew that plus bibliography as the environment means that Routledge here is one word and not route plus ledge, then the editorial hand of Word would not be tempted to take every instance of Routledge and turn it into route and ledge. So it says something about the necessity for understanding context when you're doing a good job of editing. In my pedagogical practice, I keep trying to understand what my students are saying, and it is often a very complex exercise because I can't change their words, which, you know, sometimes are some inflated version of English that I don't recognize outside of a dictionary, or sometimes, you know, just complete gobbledygook. I have to figure out, you know, what is in their minds before getting to my editorial function. So in talking about science and technology and the frontiers of science and technology, I think the question arises, you know, what is the thing that we're trying to edit on the basis of? What is the contextual stuff? And here, through many years of listening to debates at the frontiers of science and technology, what gets me are the moves that we make to decontextualize the thing that we're talking about. So very often, like Saturday, when people marched for science, and I agree with the objectives that people were marching for, but the march for science bothers me as a name for what they were doing. Much of what we do is justified in the name of a decontextualized science, and I want to talk about why I think that matters. And I want to talk about it through 4 decontextualizing steps that I think mislead us about the kind of deliberation we should be having. Forget about consensus. That already is further down the road. I want to think about who should be present at the table and what kinds of things we should be talking about. So the first disembedding or decontextualization is the one that decouples science from technology, saying that it is the march of science that we're somehow engaged with, and that splits up the very highly integrated discovery and invention process that students of science, technology, and society routinely have called technoscience. One very simple way to state the rationale for that new term, technoscience, is that in the contemporary practices of science and technology, it's impossible to make scientific discoveries without the aid of technology, and by the same token, it's impossible to solve technological problems without concurrent progress in science. There is lots of evidence of a shift from the good old days when science, quote unquote, was done by people playing with simple models in university labs like the Cavendish, whereas technology was done in industries using scaled up processes and the heavy machinery of production. Science in those days was thought to be mainly the work of the head and technology of the hands. It's questionable whether such a distinction ever existed, but now, especially with the advent of computers and information technologies and algorithms doing the work of people, it's become even harder to tell where science ends and technology begins. In my own experience, institutions such as the National Science Foundation, AAAS, and the National Academies have all made self-conscious efforts to bridge the gap between science and technology in their governance structures, their membership, and their activities. One sees this reflected in the discourse of science policy itself. We still call it science policy usually, but the US government for some time has been fixated on so-called convergent technologies, nano, bio, info, and cogno. One sees this same sort of move in the rising number of authors in all scientific fields, showing how many different skills are needed to produce scientific papers. One sees in all sorts of lab settings how the invention of instruments, materials, and technological workarounds are absolutely essential to the making of science, quote unquote. One can begin with an abstract, philosophically rich question, such as what is consciousness, and end up manufacturing chemical contrast agents that let one see how signals affect the brain's cellular matter. Science, as commonly understood, is seen as lacking purposiveness, hence the common association of science with mere curiosity and the ivory tower. Technology, by contrast, is understood to be purposive. Its usual definition is a tool applied to achieving some end. Yet if science today cannot be decoupled from technology, if indeed much of the motivation for doing work in the sciences comes from wishes to solve the world's challenges and problems, then it's useful to reflect on what is lost or erased in a phrase like the state of the science without exploring the connections to technology. A point worth noting and perhaps returning to over the next couple of days of this conference is that technology doesn't simply address the ready-made problems of the world, it reconfigures the world so as to render things problematic that were not previously seen that way. This has been repeatedly noted in connection with the life sciences and technologies. For example, in the observation that many developments, CRISPR included, may possibly falsely reinforce a notion of human perfectibility that creates new divisions in the world. Instructively, the recent National Academy's report on CRISPR drew immediate fire from the disability community, which feels that germline applications to eliminate some or all inherited conditions may exacerbate the stigma and burdens borne by those who are not among the lucky ones who are cured. But my general point here is not the one I'll leave to Glenn to think about the ethics of perfectibility per se. It's to note that talking about science alone in isolation from technology liberates science and scientists from being accountable for their own downstream effects on the world. The second decoupling puts science in a separate box from money. Science is thought to be disinterested, working for the public good and not for personal gain. But historically, science never was independent of money, and it still isn't. It's striking, the question of how science is funded and what that means for the state of science so rarely comes up in our discussions of the directions taken by our technoscientific discoveries. Last semester, I had the interesting experience of having one of my undergraduates tell me how he was so annoyed in the first couple of weeks of my course. He later became a devotee. And I said, why was he annoyed? He said, well, you made me think of the question, why am I doing the research I'm doing? And nobody in my lab had ever asked that before. I mean, you know, just this is the world talking back, right? So for many excellent reasons that we will discuss in the next day or two, US science policy has cultivated the idea of enrolling private money in the translation from bench to bedside. George's slide that Ben referred to is an example of that. And for close to 40 years, this has been the national science policy as reflected in the 1980 Bayh-Dole Act on patenting the results of federally sponsored research. There's hardly a major biological researcher in US universities today who is not also involved in one or more corporate enterprises, who is totally innocent of venture capital, who has not been encouraged to seek patents, who is not constantly put in conversation with private donors, and so forth. It would be foolish, moreover, to think that the existence of private money does not have impacts on the conduct of science. In the US, for example, stem cell derivation would not have been possible without private funds, and major university research centers carry out different types of research depending whether their funding comes from private or public sources. That private money funds research and imposes its own visions and conditions is not a matter of finger pointing or name calling. It is simply part of contemporary science's everyday contextual reality. What is at stake then in adopting a picture of science that ignores its economic infrastructure? What does it mean for the pursuit of knowledge if scientists are brought up to think in reductionist terms about the relations between knowledge and capital, that science in its essence is disinterested, as Robert K. Merton said back in 1942, and the only role of money is therefore to distort or corrupt some original purity? Do scientists themselves, and do we all as tax-paying citizens, have a duty to reflect on our respective roles in a society awash in private money, thick with private philanthropy, and ruled by the imagination of the market? What does it mean for the future of the biosciences if scientists and society can't together develop a more complex view of the relations between science and capital? The third decontextualization is political. Politics sometimes enters the discussion on gene editing by the side door, as in worries about security, where the sense that even scientists may have antisocial tendencies comes up in the figure of the rogue scientist, a figure whose politics has betrayed the science. But this idea is rooted in a common presumption that value issues arise downstream from realistic appraisals of current and future applications of emerging technologies. Missing from such a vision is any discussion of the many ways in which science participates in the making of politics, for example, through strategic alliances with power, through the creation of social boundaries that define who is inside and who is outside science, not to mention who is inside and outside humanity, and through setting the terms in which it is appropriate to discuss science in the public sphere, and many more such moves. This separation of science from politics in the sort of public discourse on science affects both the framing of issues considered germane for public discussion and the assumption of responsibility for what gets discussed or not discussed. For many in the gene editing community, scientists' responsibility is seen primarily as a matter of preventing regulation based on false understandings of risk and safety, and on communicating the science in ways that diminish the potential for public confusion. Both of those are laudable goals. But those attitudes are in tension with findings from the social sciences, suggesting that what science may see as ignorance or confusion stems, as often as not, from different framings of the issues and different ideas of the stakes involved. It has been shown, for instance, that the 1975 Asilomar meeting, long seen by biologists as a case study in responsible scientific self-regulation, produced results based on overly narrow readings of public concerns, and even the concerns of those scientists who were not molecular biologists at that time. Again, a discussion of the science taken out of political and institutional contexts in which people see and interpret science's implications tells only half the story. It leaves science's own significant framing of political issues, for example, about risk, safety, and public attitudes, largely unchallenged. The fourth disembedding, a little bit alluded to Glenn in his example of the UK and Mexico, is cultural. Though the word culture often surfaces in discussions about gene editing, it is usually invoked to suggest that other cultures, not ours, may have different values that we need to take note of. The recurrent observation that if we don't do something, other people with presumptively less responsible values will steal a march on us is often advanced as justification for steaming ahead. In such conversations, there's an apparent sense that science and culture are distinct domains, each with its own discrete norms and obligations. More specifically, while estimating and assessing risk is widely seen as scientific, ethics is seen as being primarily cultural. This perception of science as lying outside of culture is not limited to scientists, but is shared by many thought leaders in law, in media, and in politics. Here is where a bit more cross-disciplinary exploration might help, and I'm really glad that Anthony Appiah is present, at least in his written words, to take up parts of this challenge. The presumption that science is universal and acultural, whereas ethics is cultural and therefore variable, overlooks a fair amount of cross-national comparative research, suggesting that how one deploys science to frame, demonstrate, or contest risk and benefit is itself grounded in political culture. There are far-reaching differences between cultures in which, at the limit, science is considered to come first, to declare what is possible, and ethics is engaged only afterwards, to pass on the implications, and those other cultures in which ethics is thought to come first, creating the normative framework within which science is allowed to develop, with risks being assessed only in relation to already negotiated social ends. These are not just hypothetical differences. On the whole, in the regulation of biotechnology, the US corresponds to the first position, science first, ethics after, while that of some European countries corresponds more to the second, ethics first and science after. Now, one could say that this is part of the basis for Glenn's skepticism about consensus, but my point is that before we even get to that point, we have to think about the terms in which we're talking about these issues. So as we consider the principal topic of this conference that Ben laid out, how do we develop a truly international deliberative forum, note not consensus, for discussing the future of gene editing and the suite of related technologies? I hope we can overcome some of these disembeddings that ease our discussions now, but may only kick the can of legitimate dissent and resistance further down the road of humanity's common future. Thanks.
All right. The recent National Academies of Science and Medicine Joint Report on Human Genome Editing endorsed both somatic and germline editing research and somatic genome editing, recommended limiting severely clinical germline gene editing, and urged against editing for enhancement, which they defined as, quote, human genome editing for purposes other than treatment or prevention of disease and disability, end quote. Some objected that the limitation on germline editing was not absolute, but the bar to germline enhancement for the foreseeable future looks pretty strong. Two distinctions are presupposed here. One is the therapy enhancement distinction. The other is the germline somatic cell distinction. Appeal to such distinctions exemplifies a feature of the way in which human beings respond morally to new technologies. We persist with distinctions that have proved useful already. But where have these particular distinctions previously proved useful? Well, the soma germplasm distinction is relevant for ethical purposes because somatic alterations don't enter the gene pool and travel into future generations. Because we get our mitochondria from our mothers, mitochondrial transfer, even if it involves manipulation of the mitochondrial genome, will only produce changes to the gene pool if it is done to a female embryo. A boy whose mitochondria were donated cannot pass them on. And in the two recent cases where this occurred, in the Ukraine and in Mexico, the medical team did indeed make sure that the child was a boy. So in this case, a familiar distinction misleads. That is a point about biology. But if we turn to the therapy enhancement distinction, the question is more centrally ethical. This distinction is used a lot in thinking about which forms of medical intervention constitute the delivery of healthcare, and so should perhaps be publicly funded, and which should not. But as Norman Daniels has pointed out, it doesn't match up at all precisely with the moral lines we actually do or should draw. Pregnancy isn't a disease, but many people think that abortion should be covered alongside other medical procedures. That claim is controversial because some people think abortion is wrong, not because they think it's not therapy. It's a bad idea to think that only therapeutic interventions are morally permissible or that only they should be publicly funded. Philip Kitcher pointed out that a germline genetic intervention to increase the efficacy of the immune system would be an enhancement, but a very good idea. Of course, an effort to improve the immune system is exactly the sort of thing that easily goes wrong. An overvigilant system gives us autoimmune disorders, so it might be hard to get the balance right. And in all germline interventions, we're risking creating a monster. But all we can say to someone whose life is biologically compromised from the start by unsuccessful gene editing is what we should say to anyone born with biological challenges, however they were caused. We did our best in the light of what we knew. Even if you adopted the principle of caution proposed by Jonathan Glover, which weighs downside risk more heavily than upside possibilities, it's hard to see why this would lead to ruling out germline interventions altogether. The plausible ethical worries about germline enhancement are not, in my view, not my view, but about whether the results will be good for individuals or the gene pool. It seems obvious that they could be, but whether they will be good for society, let me read that sentence again, I'm sorry. The plausible ethical worries about germline enhancement are not, in my view, about whether the results will be good for individuals or for the gene pool. It seems obvious they could be, but whether they will be good for society and our moral life. And so let me end with two important kinds of worry. First, genetic enhancement might further increase the forms of inequality that are already too evident in our world. If people can secure advantages for their children through germline enhancement, this will be able to get them even more social advantages that are already created by access to greater cultural, financial, and social capital. But these are worries about the distribution of genetic enhancement and its social consequences, not about enhancement itself. A germline intervention that left everybody with better immune systems, the way universal vaccination already does, is not open to these distributional objections. And it may be worth observing that there's a pattern in the history of technology where the rich effectively subsidize technological development for the rest of us in return for being the first at the buffet. Once cellular phones were expensive things that moguls used, now my smartphone is as good as Peter Thiel's, maybe. Once home computers cost $50,000, and once decoding a genome was a difficult and costly endeavor. Then the technology becomes cheap and commonplace. Something like that seems likely to happen with CRISPR-Cas9 or whatever succeeds it. There is, however, one ethical challenge associated with enhancement that I see as having some force. Ronald Dworkin defended Aristotle's view that, quote, a good life has the inherent value of a skillful performance, end quote, and proposed what he called, quote, the model of challenge. It, quote, holds that living a life is a performance that demands skill, that it is the most comprehensive and important challenge we face, and that our critical interests consist in the achievements, events, and experiences that mean that we have met the challenge well, end quote. Now, what makes life a challenge is that there are limitations on your natural capacities. Suppose it were possible, through germline genetic engineering, to create people with any combination of capacities that has ever been within the range of human possibility. You could have Michael Jordan's fadeaway shot, Mozart's musicality, Groucho Marx's comic gifts, Proust's way with language. Suppose further that there were no careers or professions in this world because intelligent machines met all material needs and services. Far from being a utopia, so it seems to me, this would be a kind of hell. There would be no reason to celebrate any of these options because there would be no achievement in putting together a life. Nietzsche made clear why. Quote, one thing is needful, to give style to one's character, a great and rare art. It is practiced by those who survey all the strengths and weaknesses of their nature and then fit them into an artistic plan until every one of them appears as art and reason, and even weaknesses delight the eye. End quote. To create a life is to create a life out of the materials that history has given you. Even if you outshone your contemporaries because of the sorts of enhancement I just sketched, if you knew that this was how it was done, that you were made as an ideal model of a person, could you really value your own achievements? Or rather, wouldn't you want to take up challenges that were harder? And then wouldn't we face exactly the sort of pointless arms race that has led us, as Bob Frank has argued, to a world in which people seek ever larger houses just in order to have a house that is bigger than their neighbors? This is a fantasy. That resonates with me. I'm from Phoenix. This is a fantasy, of course. None of this is anything close to currently possible. Some people think it will never be. I don't worry about individual cognitive enhancements by genetic engineering any more than I worry about achieving them by implanting computer chips. Provided the advantages are open to all, it seems not worse but better than giving everyone a terrific cell phone. You could certainly argue that we should distribute these exciting enhancements fairly, as I say. But as we set off down this path, it is worth remembering that human significance derives from meeting the challenge set by working with the capacities we have. New capacities would bring new challenges, no doubt many hard to imagine now. It would be a mistake to think that in enhancing our capacities, we were going to be able to transcend the fundamental human situation. We will still have a nature, even if, as with the slower paced changes of natural selection, it is a new and constantly changing one. And living well will still mean working with the limitations set by that nature. Okay. Now I'd like to open it up for discussion, but I'd first like to invite the panel to raise questions for the rest of the panel, if you so wish. Does anybody want to start us off? Sorry?
I think we're happy to.
No takers. Okay, so I'll invite questions from the audience. Yes.
You have a mic? Oh, thanks. I'll just preface this to say that I am the father of a beloved 57-year-old daughter with severe mental handicap and uncontrolled epilepsy. In 1963, I was on duty at Children's Hospital when I was called to the emergency room at 3 in the morning to take care of a child, 20-year-old boy who was brought in a peach basket by his parents. He was a single gene abnormality that was cared for by the metabolic unit in the hospital. This lesson to me is that this will happen, that the single gene, that penalty to those parents is inexcusable. The question is not whether, but how and when. Thank you.
Okay. Other questions or comments?
Good evening. My name is Nico. I'm a fellow within Sheila's group, and I'm also one of the co-founders of the Future Society. I'd like the panel to try and help us clarify one aspect, which is that there seems to be two ways, or at least two ways, through which editorial aspiration can manifest themselves. And CRISPR-Cas9, family of technology, seems to be, in the systemic context that we're having, putting pressure onto and through pregnancies. It seems to be through reproductive technologies as opposed to gene therapies, therefore through intergenerational manifestations that these aspirations will manifest themselves. Is this right in your view, or are there parallel paths that we should be looking at? Because so far my take is mostly reproductive.
Your question is CRISPR or gene therapy mostly reproductive? Is that the question?
Editorial aspiration, the rise of gene editing technologies open an era of editorial aspirations. There are various routes through which these aspirations could manifest themselves. It seems that CRISPR-Cas9 could impact the way we're designed, mostly through reproduction. It's not that we could, through other forms of action, impact my design tomorrow and grow me a third arm, let's say. It's mostly through reproduction.
I would answer that by saying, right now, it is mostly not through reproduction. That is to say, most of the breakthroughs, most of the financial incentives are somatic. That is to say, they the four companies that are in Cambridge are all aimed at adult or child gene therapy, not germline. And transplantation methods are also aimed at children and adults. And those are very promising. Now, that doesn't alter the fact that in the future there may be such a slippery slope, but I would say right now, the markets and the work on the ground is somatic.
I'll also add that enhancing ourselves versus enhancing our children, or altering ourselves versus altering our children, have kind of a branch in the argument. So, as you could tell from my talk, the arguments are still familiar, but they're different categories of familiar arguments. When it comes to altering ourselves, on the one hand, it makes it somewhat easier is that we are making decisions as individuals who suffer from these diseases and have experience or want these enhancements and have experienced their current way of life, and at least the ability to imagine what the current life is. So that makes it easier. What makes it harder is that you have an entity that will be harmed or benefited based on the way in which the action takes place and what the results is. When it comes to embryonic manipulation, there is a philosophical question about what level of manipulation is sufficient to create a different entity, such that it resembles not, choosing to have child A versus choosing to have child B, as opposed to merely improving child A versus not improving child A. And so I think that this is a difficult metaphysical question. At what point an alteration is sufficient to disrupt identity such that we can think of that entity as harmed or benefited? I'll also say that a certain strand of this literature is focused, I think, from a virtue ethics kind of way on the virtue of parenthood, and views kind of attempts to enhance or to alter as to be, or at least alter and enhance too much, right? Not a problem to try to vaccinate your child, but a problem somehow to perhaps alter your child to be immune to all diseases. Views it as a kind of disfigurement of the child-parent relationship, right? You see this in Leon Cass, you see this in Michael Sandel. And that particular strand of the ethical concern is less present when an individual is altering themselves. So just to say that apart from the technology and the question of where the technology is going, each of the two options has some overlapping arguments, but some separate arguments, but again, familiar ones.
Question here.
Yeah, I'd like to hear talk about the process of societal or political or public decision making around, some or all of the things that you've been talking about. I mean, clearly there's a scientific movement that researchers, perhaps for financial reasons, perhaps for intellectual reasons, perhaps for moral reasons, are pursuing this research. But how do we think about who ought to be making decisions on where to stop, where to proceed, where to fund, where to set limits? That's a complicated enough issue within a single country, but then, of course, there's the international arena, which is even orders of magnitude more complicated. So is this something that sort of experts ought to be deciding through conferences like this? Is this something that we ought to have sort of public community debates? Is this legislation? Is this courts? Is this elected officials? Who and where ought to be thinking about these issues? Maybe all of the above, but then what do you do?
I'll maybe just start real quick, is to say, if you wanted to ask me somebody who's done this well in this sphere, I am an unabashed fan of the way the UK handled the mitochondrial replacement therapy debate. It was not simple bioethics by democracy, voting, or polling. It was multi-level public consultation, plus Nuffield Council and others weighing in with expert kind of articulation, plus widespread parliamentary debate, plus newspaper battling editorials, including the Archbishop of Canterbury, and ultimately a legislative decision in Parliament. And if you read the transcripts of the parliamentary debate, it was far from perfect. There were elements of it that made me cringe, but I would say it was head and shoulders ahead of what I could imagine being the equivalent debate in Congress, in part because we no longer have debates in Congress. Instead, we have speeches read into the record.
So my answer is a bit different from that, because I think that one would have to put the UK process itself in its own context. So, one quick plug for tomorrow. The entire session all day is devoted to unfurling a complicated, multi-layered response to Jennifer Hochschild's question by looking at what kinds of values are attached to the human and what is trying to be protected here, what scientists themselves believe are the legitimate endpoints of these technological interventions, and what science is afraid of or wishes to promote, by looking at deliberative bodies that exist in multiple countries and by seeing their relationships with publics. So we're actually trying, to some extent, to have an inventory of the ways in which these things have been approached. But with regard to Glenn's question, I will say that, I mean, first of all, I'm a little bit amused that Glenn is such an unabashed supporter of the one system that has produced consensus fairly reliably in this contentious world. So it seems that although he's deeply skeptical, he does believe that we should all become like the UK and foreground consensus. But you know, there are some British representatives in the audience, and they may believe that, for instance, the sudden consensus on Brexit was perhaps produced in terms of that might not pass the first tests of deliberative democracy. I mean, that is, one can have consensus and yet be somewhat hampered in one's, you know, sort of ability to congratulate the consensus builders. Both the Nuffield Council, which was mentioned, and the sort of major public consultations, which I also admire as far as they go, work to some extent by excluding genuinely different kinds of opinions. I mean, you know, the nature of the British polity is not a perfect reflex. If any of you have seen pictures of David Cameron's cabinet, for instance, you might have recognized that, shall we say, it was not exactly a cosmopolitan entity. So I think that one does have to get behind these procedures and ask what else is going on. And what I was trying to bring to light through my talk is that there is a lot else going on if one recontextualizes the doing of the science and the technology. I don't know if you...
It's a bit hard to... I apologize for on Delta's behalf
it's not united.
for having delayed me for 3.5 hours for reasons that are not entirely clear to me. So it's rather hard to enter a conversation that's already ongoing. I would say that in my own thinking about these things, I distinguish very sharply between, as it were, questions about what I think should happen, and then questions about how I and others who think like me should persuade everybody else to go along with what I think is the correct view. So I think it's important to distinguish between, as it were, various process values and things that are then I think we should hope to hold on to as constraints on the outcome. And I didn't follow the British process, but you could imagine that if we followed a sort of roughly parallel process here, as you suggested, Glenn, it would have different outcome. And so maybe, as it were, what you like about the British process is what it ended up with. And then I think, you know, thinking about how to do the politics here, and then even more difficultly, as I mean, Jennifer asked about the international system, it's even more difficult to figure out, as it were, what would happen if you just let one of these one of the many possible UN type routes go. It's very hard to predict, I think, whether we would like the outcome. So I think, I mean, and a lot of the questions in there seem to me sort of strategic and tactical rather than ethical. I mean, there are ethical constraints, but a lot of it is just strategic and tactical. How are we going to get to a relatively good outcome while respecting you know, democratic values and the views of a wide range of the world's citizenry and so on.
I'm going to actually take chair's privilege to just interject a question here and ask Professor Church. You said something like there's a sense in which society's norms may be at risk, and yet this is a construction of risk that FDA doesn't use in its evaluations. One of the things that's interesting about this mitochondrial replacement therapy evaluation process is it's quite focused. I mean, it's very narrowly focused on a particular technique, and much of the discussion was, when we're having a discussion about this technique, are we talking about other things that are further down the pike or not? And there was a lot of push towards no. But so I wonder, Professor Church, if you would comment on, when you think about the sort of horizon of scientific possibilities and the things that you think need thinking about vis-a-vis broader forms of risk than very specific, narrow assessment of particular interventions. What if you'd say something about the level at which you think we should be asking these questions? Is the specific application the right level? Is the research trajectory the right level? Is the conceptual commitments that are upstream of that research trajectory about where one ought to go or not go the right level, et cetera?
Well, all of those to some extent. I think it's a difficult question. I think the point about, say, parenting of mitochondria, since two mitochondria are so similar, unless you were to pick a parent who was diseased, you would hardly know the difference. If you were to introduce a point mutation into a mitochondria, or for that matter, any of the other chromosomes, does that mean where you chose that point mutation is apparent? I think these things are way beyond the scope of the FDA. And at the level that we have to do it is, some of it has to be in terms of research priorities, because some things, once they get far enough along, are very hard to reverse. For example, gain-of-function flu virus, you introduce into the literature a very potent pathogen that's unprecedented, because you didn't have a policy in place proactively to control that. On the other hand, you may not want to control that, but at least it's certainly not as intentional as it could have been. But you also need, that's at one end of the spectrum, is to guide the order in which we do research in a constructive direction. But at the other extreme, you have case by case. It's very hard to come up with algorithms that are so general, especially with technologies that are so new. So I think there will be a great deal of case by case decision making.
Ken.
Ken Oy from MIT. The question that I have goes from Jennifer's comment on ought to a question on will. What's going to happen? We observe, and again, the panel has done a great job, and particularly I have to say, Glenn, of noting that there is no consensus, that we're likely to have quite different national standards and policies on all of the issues that we've been discussing. So the question really is, what are the consequences of disharmony or disunity, differences in standards, not in general, but on the specific applications that you've been talking about? For human germline modification, it is extremely unlikely that there will be one common standard or policy, and things will proceed independently in different jurisdictions. For somatic cell gene therapy, there will be differences in reimbursement as well as licensing that will be taking place. If we turn to gene drives, there, the technology offers a difference in terms of the potential for altering the genetic commons and for producing externalities. And once again, I see no evidence of consensus. In fact, disunity is the norm in regulatory affairs. My question to the panel, both technologists and policy people and ethicists, is where does this take us in each of the areas, and in what areas are you most concerned?
Well, Ken, I mean, first of all, one doesn't only have to begin with germline gene editing. Name me a significant area of human life and concern where disunity is not the rule around the world today. So how does humanity survive in spite of disunity? There have been formulas. This country was founded on a notion that disunity actually led to ecological style robustness. as the metaphor of the 50 states as experimental laboratories suggests. And what we've tried to do is adopt a multi-layered response to that. That is, when through experience we learn that certain things are so foundationally important, we kick it up a notch. So if it's about not just intimate relationships within the family, that we have said, subsidiarity is the right principle and throw it down as close to family life as possible. And, it doesn't matter if people have different divorce legislation across different states of the union or different, ages of consent or whatever. That's okay. In fact, we can live and learn from each other, and we can let something like Oregon emerge as the state that does public health best, and then eventually through best practices we can harmonize. So that's one approach. But then we've said about other things, and we've changed our minds on these things, like capital punishment, which we're seeing enacted on the national stage right now, and like sexual relationships among different kinds of people. And we've said that when, in the course of human affairs, something becomes that significant, we do universalize it at the next level up of government. But as you see from the current political context, even that is never permanent, right? I mean, you can withdraw from a union that you were in and you kick things upstairs. So I think that the disunity per se is not the issue, that when that disunity becomes problematic is the issue. And my own view about these things is that the disunity is actually productive if it makes the society look back into itself. And I don't think we often do that. That is, I think we fixate on the disunity and say, we're the reasonable ones and they have the culture. So, they should look into why their culture is making them do different things, not, hey, our reason is also a kind of culture and why are we doing these things in this way? I think that until we cultivate that sort of habit of reflexivity, we're not actually going to get to some kind of more sustained kind of normative convergence. And of course, at the end of the day, I'm not sure that on everything we need the normative convergence either.
So I think I'm intrigued by Sheila's answer and by your question. So let me kind of sketch two models depending on what you think is scary about this area. If what you think is scary about this area, thinking about Anthony's talk and other talks here, is the kind of society we would become if we allowed this to happen. This idea that we would be traversing not kind of a consequentialist line, but a kind of an intrinsic line, or one about the virtue of our community, what kind of political community. I think it is easier in same-sex marriage. I think is an odd but an interesting analogy. It is possible for jurisdictions to exist, some that recognize it and some do not. And of course, it's an affront to the one that wants to reject it. But it is not as though there is infection or contagion as a result. So if that is your concern here, I think it's possible for us to say, we're not Canada, or we're not France, or we're not Denmark, and the like, and just to say, we disagree, but this is our polity. On the other hand, if your concern is a much more tangible consequentialist one, I think Gene Drives is in some ways the most tangible version about this. The things that you do there will not just in a semantic or theoretical or kind of virtue sense infect the way our people think, but actually make its way onto our shores. Then I think the disunity is much more threatening. And even just thinking about germline gene alteration or mitochondrial replacement, imagine the U.S. adopts a strong position not to allow these things to occur. Well, our 17 and 18-year-olds go backpacking. They have romantic relationships with people born abroad, some of whom will be the results of mitochondrial replacement or germline gene editing, right? These people get pregnant, they have children by accident, they want to bring the children back, right? Are we really going to have a position where we will so carefully protect our shores from these activities as to create a litmus test for reentry back into the country, that seems fanciful and difficult. And so to me, when it comes to the consequentialist kinds of concerns, it's not a matter of yes or no, it's a matter of how much. And how restrictive we are will determine how many of these things make it to our shores, but it seems fanciful to think that none of it will.
Well, I mean, yeah, that's very important because whatever regulations you thought of passing, nothing consistent with our ordinary understanding of what it would be to engage in normal political behavior would be consistent with essentially trying to maintain two distinct human gene pools, or N distinct human gene pools for the foreseeable future. That just doesn't seem to make any sense to me as a proposition, as you were implying. And so we can't be indifferent to, if we think something's going wrong in this area, and maybe I'm more sanguine than some others about that, but if we think something's going wrong in this area, we have to try and use whatever apparatus we have transnationally to try and, because there's one human gene pool, essentially. So it's a commons. It's something we need to look after together, and we have to use whatever institutions we have to explain why we think there's a problem, and then to try and do something about it, as we do with, say, with the climate. You can't have an American climate and a Chinese climate, and say, okay, we'll just regulate them by ourselves. We have one biosphere. We have to do whatever instruments we have to negotiate about it, and that's, we're not doing a terrifically good job, but we're not doing nothing in that domain.
Since we're past time, I'm inclined to take one more question. Yes, right up here in the front. Somebody have the microphone?
Yeah,
Would you mind bringing it up?
She can answer.
I think our runner took off. Thank you.
Thank you. I actually come back to the notion of consensus. I'm quite sensitive to that because I'm an intergovernmental organization, so I know what it means. But I understand your comment, Mr. Cohen, on this is not a solution in this field, and I've heard it as if it consensus on the end result, it's sort of whether an application is acceptable or not. But I'm wondering whether there is other level of consensus that would still be a step forward, without bringing a yes or no type of answer, but consensus on what are the questions to be addressed, who are the actors to be involved, what are the mechanisms. We talk about public debate, what does that mean? What do you think of that type of consensus? Do you think it's achievable, and whether it's actually a step forward already?
So I'm a little bit more hopeful, but only a little bit. And let me just tell you where I am hopeful, where I'm not hopeful. I'm somewhat hopeful on the question of who is within the political community who ought to be listened to in some way or another. Not completely hopeful, because I think actually interesting problems of cosmopolitanism and questions about thinking about other countries and their representation, I find it hard to think that we will reach a point where we will be that open in this country, at least to use an example. Where I'm the least hopeful, I think, is consensus on the question of secular versus religious reasoning in this area. And this was on display somewhat in the UK process, right, and that there were religious voices. But I find it hard to think that we will reach consensus on whether purely religious objections to remaking human beings are within the sphere of public reason or not. Now, maybe we'll just default to the most, inclusive kind of discourse, but I'm somewhat skeptical that those who are skeptical of religious voices will accept them, and I'm somewhat skeptical that people who believe in religious reasons for opposing this research will want to dialogue without that plank. But that's me, and I'm a lawyer by training, so I'm a skeptic and a cynic by nature.
Just it's going to go the other way as well. Of course, the religious people are not going to be interested in a conversation in which the dominant technical advice is given by people who appear to be non-religious, and of course vice versa. So it's hard to see. But on the other hand, I do think I think we should try. I mean, weird things can happen. People can come to weird kinds of agreement, and I think they can come to policy agreements while still having very diverse grounds for accepting the policy. And depending on what you think about the some of the more sort of metaphysical objections to gene line editing. There are some of the opponents of those are not religious, and some of the arguments are not religious arguments. So I think there'll be lots of interesting possibilities. But the really important thing is that given that this is a problem that involves everybody, we do have to have the conversations with as many people as possible, because that's the only way, as far as I can see, it's going to get done.
Would you say, though, a word about those categories themselves and what you intend
Which categories?
of the religious and non-religious, since you've written about
Yes.
the fact that those mappings are consequential in
Yes.
themselves.
Okay, so yesterday at Yale I gave a lecture on why I didn't believe really in the category of religion. So I was using a term which I'm somewhat unrelaxed about. I mean, in a way, what I feel is what's important is to get people into the conversation, and probably not helpful to spend a lot of time arguing about who's religious and who's not religious, and who's bringing in metaphysics and who's just being practical. People will bring in the things that matter to them, and I'm afraid that's what politics is about. It's allowing people to bring in the things that matter. And the Archbishop of Canterbury, as you mentioned, delivered himself with views about this matter. Lots of people in England are interested in what the Archbishop of Canterbury thinks about that. It seems perfectly proper that he should be one of the voices. That's part of his job. And we can't exclude things because we have some philosophical principle that says that a reason of a certain kind is for some reason excludable. That's not how politics is going to work. We do have to. I mean, I think, the more the people who understand the technological possibilities present a sort of consistent and coherent view, the better it is going to be for the discussion. I think, I mean, again, think about the climate problem. There, for various reasons, it's been possible to at least pretend that there is, as it were, there's serious dissensus among the experts. And once that happens, it's very difficult. I mean, if you're a serious religious person, you want to be guided by the truth, right? Including the truth about science. But you also are going to be skeptical that someone is going to, not to cheat, as it were, in the argument, if they're not guided as you are by certain kinds of general metaphysical considerations. So I think it's important to have, as it were, the technical people get as straight as they can, as much of what they can get straight about, in advance of, and to present it in a way that's not manipulative, but just as clear as possible. And listening to the debates among the technical people is not going to help non-technical people, I think, figure out where they want to come down. So
anyone else on the panel want to have a final word on this or anything else?
Just a couple of very quick observations. So, of course, whatever those categories, religious and secular, mean, they can be instrumentalized. And I will never forget a conversation I had with Mary Warnock about what was, after all, one of the most famous consensus documents in the history of bioethics. And she told me that 3 people dissented from the majority opinion there, but she said that that was very important. It was important to have that dissent because you had to give the Catholics a voice, and everybody knew that they would dissent. But, so my question about all of that is, I mean, so this is a very savvy person who's a moral philosopher, who is also a politician, talking about her advice to government. But my reflections on that are not so much about what Catholicism means in England, although one could go off in that direction, but to observe that that there are meta rules in the society that may not ever be expressed in these sorts of discussions. And I think that if there's one overarching point I'm making, it is that in these sort of dialogues among countries, among different sort of cultural formations that lead to the production of public reason, one has to keep going back and asking, well, what are the pluses and minuses? I mean, Britain may have secularized the territory, but at what cost? Which views are not getting exposed? And, you know, I think history speaks to the idea that it's not just, you know, getting a diversity of people there, it's that you bury things at your peril. I mean, that they resurface when you don't expect them to resurface. And you could be marching along for 50 years, producing consensus on a general presumption that, you know, sticking the minority into the dissenting position has satisfied your norms of democratic accountability, but then something happens, you know, and I think that we are maybe not good enough at observing those warning signals and, you know, knowing when to take care that maybe over and over again we've marginalized minorities. I mean, George spoke of one facet of this when he was talking about the fact that the majority can actually impose a kind of rule that I think our first commentator was also calling attention to. But I think that that's a far more general phenomenon and, you know, something that I mean, more than having the diversity, I think we need to cultivate an awareness of, you know, where we are coming from in our own sort of predilections.
Any other last words from you, George, or Feng, or Glenn? No. Okay. Well, in that case, let's thank our panelists.
Then you might just announce where tomorrow's thing will be.
Yes.